All right, so the question is find the area between the two curves, right? That's correct? That's what the actual question says. So if we're finding the area between the two curves, one is sine x and one is cos x, and then here are our limits, okay, or our boundaries, A and B. So a quick sketch here, that's unfrozen. A quick sketch looks a little bit like this. Let's do sine x in blue. So sine x generally looks like this. No, that's from 0 to pi, right? Because the full sine x continues to 2 pi. This is what the other half looks like then, okay? And cosine, which we'll do in red, just a rough sketch again, starts at 1 instead of starting at 0, and then sort of mimics this, right? So we've got this, and then we've got this, roughly, okay? So between negative pi and pi, right, we have, so this would be negative pi here, negative pi, and we have positive pi over here. So if this is drawn maybe a little bit better, I didn't draw this, I wouldn't say I drew this real well, but we see that we have a number of sections, looks like. So there's going to be a section here in between. There's going to be this section here in between. And there's going to be this section here in between. All right, so let me just pause for a second. Okay, so he sketches something graphing calculator very close to what I drew. So that's a little bit of an ideal. Now, what we have to do here is then split this into several sections, right? We don't worry about the x-axis really at all. We don't have to like think positive, negative, and all that. We just take the difference between the upper function and the lower function for each section. So what we have to remember is that this is the sine x and this is the cos x. So from negative pi, okay, from negative pi to this intersection point, which we're going to have to find these two intersection points, okay, and that shouldn't be too hard to do, but in this first section, the sine graph is on top. You see, this is the sine graph on top and the cos on the bottom. For this middle section, the cos graph is on top. And for the final section, the sine graph is back on top. Okay, so we've got sine on top here, then cos on top, and then sine on top again. Okay, so we've got 3 sections. And again, I'll just kind of get you started on this to make sure that you're well on your way. Did you get this far so far in understanding what the areas are that we're looking for, those that had trouble? Yeah. Okay. So we need to find these intersection points. Why? Because we need to be able to split these sections up into three pieces. So we need to find out where cos x equals sine x, right? And we can work we can work with the first quadrant. I mean, think about the unit circle. We can think about the first quadrant if you want. That's going from 0 to pi over 2. We have to think about the second quadrant as well. And we also have to think about the third and fourth quadrant, right? It's kind of like here to here, so we have to carefully consider that. But remember that at 45 degrees or pi over 4, we have the sine and cos being equal. Remember that? So we have x would equal here pi over 4, right here, this angle. And then we have this angle, and this angle. So pi over 4, and then what's this one? 2 pi over 4, 3 pi over 4? Okay. And then going to negative pi, we have also x equals negative pi over 4 and negative 3 pi over 4. Is that right? Okay, so now from negative pi to pi, so we have pi over 4 looks to be this one right here, right? That's going to be pi over 4. This appears to be right here. This appears to be negative 3 pi over 4. Is that right? Okay. So, oh, you know what? Sorry, my bad. We don't want to consider these ones because this one is negative, one's positive. Yeah, and here too, one is negative and one's positive. So we are not actually worried about these ones. We're only considering these ones. So, sorry, this is plus and plus. This is minus and minus down here. Yeah. So that's a good thing we sketched, right? It's early in the morning, and you guys didn't catch us either. But you see, they're the same here in the first quadrant. That's pi over 4 right there. And they're also the same in this third quadrant, negative, right? So that's why you don't see any intersection point here at negative pi over 4, right? There's no intersection there because they're not the same. One's positive, one's negative. And you don't see any intersection point here because that's over here, and one's positive, one's negative. So they're only the same at negative 3/4. That would be this one, negative 3/4 pi, and then positive 1/4 pi. So this one is out, and this one is out. Okay, got that? Those are the two intersection points. So that splits up our area function, really. So I want to take this area right here. So area 1 is from negative pi, right, to negative 3 pi over 4. And then area 2 is from negative 3 pi over 4 to positive pi over 4. And area 3 is from pi over 4 to pi. And if we keep moving on here, we remember that the sign is on top. So this is going to be sine x minus cos x for a function that we're going to take the antiderivative of. This one is cos x minus sine x. And then again, sine x minus cos x. So I'm going to stop there because only a small fraction of you have attempted this question yet and are having trouble with it. So you need to find each area by finding the antiderivative of each function and then evaluating it at the far right boundary, subtracting the evaluation at the far left boundary, and then add them all up. Okay? So I'm going to stop there. That's the kind of the intro to that one. It takes a while, this question, but okay, are there any questions up to this point? Or are those of you that are tracking with me here, you guys are good up to this point? Okay, so I will let you do the rest on your own, and you can check with me in a bit for the answer, okay? All right, so to conclude 1-0, if you want to look here, we've got our two intersection points. If you keep in mind which function is on top and which function is on the bottom for each of the three sections, you should get a total area of 4 root 2 units cubed. I do appreciate when you put the units, or sorry, squared. When you put the units there, that always completes it. It is an area. So it should be 4 root 2. And I didn't finish by hand here, but I did start going here. I got distracted helping the students. But this would be your the function, combined function for area 1. And when you take the antiderivative here, you get the sine becomes negative cos, and cos becomes positive sine. So you get this as your antiderivative function for area 1, and then you take the far right boundary, put it in, and then minus the same expression with the far left boundary, and then I don't know if they've got it here or not. Yeah, it looks, I don't know, I can't really tell what it is here, but anyways, looks like it should be 4 root 2 as a total area when you add all these up. So
I think I would have gone it right with my way. I just did it all backwards.
Your way was right, except it was completely backwards.
No, but it wasn't.
It's close. That's close.
It wasn't.
Nice work.
I took the lower number. So
Yeah.
if I did the higher number, it's subtracted. But I'm doing it.
You're close.
I didn't know you could.